Hello everyone. In this module, we are going to be using what we've learned so far as different modules, different functions, whatever we've learned so far, we're going to put that in use to get to know a new data set and clean it, do some data pre-processing, and also detect missing values and also outliers and deal with them. So the first video is going to start by just getting to know the data set and doing some pre-processing. And the second video, we are going to be focusing on missing values in this data set. And the third video, we're going to be focusing on the outliers. So let's get to it and get to know this data set. Okay, this is an electricity data that comes from Belgium. It's electricity data, consumption data for a whole year. Actually for more than a year from Belgium. So let's go ahead and import our module and also read the data from 2017 and 18. So you can see that this data has 3 columns. You have date, time, and consumption. Pretty simple data. As you look closer, you can see the time window or the time jumps or the intervals here are every 15 minutes. So you can see that this consumption is for the 15 minutes of that window of time. So this is the structure of the data. Let's get to know a little bit more. So we say DF shape, we already know it has 3 columns, but it has 36,742 rows or data objects. And then let's go ahead and see what's happening with the consumption. What is the minimum, maximum, mean, standard deviation, all of those things. So the minimum of 15 minutes consumption has been 30,000 and the maximum has been 109,000 and the mean is 56,000. So it's sort of like giving us an understanding of this data. But it's just some numbers and it's still we have a better way to go about this. So in this challenge, we're going to figure out a way to actually get a better sense of this data using visualizations. So in this video and the 2 videos after this, we are basically going to go through a number of challenges. I mean, there is nothing new about the codes or the things that we are doing here. We're just going to apply what we've already learned to really pre-process this data set. So I'm not going to stop at any point to give you a chance to do it yourself. I'm just gonna like talk through them. But if you wanted to give it a try yourself, before I move on in this video, stop the video and give it a try and then continue. I'm not going to purposefully have those breakpoints in the videos. So let's continue. So here we want to come up with a visualization that sort of does the same thing here. And there are 2 visuals that we can come up with actually. There is like histogram and also Boxplot. So you can see the Boxplot is telling us what is the median, what is the maximum, what is the minimum, and if there are some outliers in the data or like flyers in the data, and sort of like gives us an understanding of where the data is. So the majority of the data is between 45,000 to 60,000, but it's not odd to have data in 65,000 to 95,000, but it is sort of odd to have after that. And the minimum value is around 30,000, as we saw in the describe. And also histogram sort of gives us the same information about the data. We can also see what we were seeing there, but it's more detailed. We can actually see the shape of the data. We can see if it's skewed, and we can also play with the number of bins and change the histogram in a way that it's going to work for us better. So now we have more number of bins, and we can see that there is unusual, not unusual, there is much more data before 55,000, and then there is a rapid decline on the frequency of data after that point. And we can also see that there is unnecessary emptiness here, which basically means there are some data here that are happening or their frequency is so low we cannot even see them here. And we can see the box plot, actually this is easier. We are actually seeing them as those fly. Well, basically this challenge is going to sort of get you to think about what are the benefits of each of these two visuals as far as giving a sense of a population. We've already discussed this as I was going through this. Both of them are very useful, but Boxplot are great at detecting the flyers and also sort of giving us the where those important quantiles are, as we saw in the describe, sort of gives us a understanding of where they are on in comparison to one another. But histogram is much more intuitive, and it's sort of it's much closer to the way our brain works. So histogram has that intuitiveness that Boxplot doesn't, and both of them are useful, and you could be using them for getting to know a population of data. Challenge 3. So we want to see sort of get more information about other column, about the date and also time. So we want to see if the dates are formatted in US or European format. In the US format, the month comes before day. In European format, the date comes before month. So we want to just check that out, see if which one is the case, as we are going to be using the data. Also, we want to see if this data is only 2017. So let's get started on this. We can go ahead and split the data based on the slash. So you can see that all of the data, all of the time, they are divided by slash. So if I divide these data by slash, or split the data by slash, I will get 3 different elements. I know the last one is year, but I don't know which one is month and which one is day. So I call the last one year, and I just call this MD1 month or day, we don't know, or month or day 2. So I run this, now I have year, month or day, so let me actually do this to 5. And now I can say .unique, year.unique, and it basically tells me the unique values that exist in this column. And they are 2017 and 2018. And since I only want to work with 2017, I don't want to work with 2018, I can simply just keep the 2017 ones using the Boolean mask. So I'm just saying, whatever there is 2017, create that mask, filter the data using the mask, and whatever you have, keep that data. I only want to have that part of the data. You can also see I'm doing the same thing with the same Boolean mask for both of my data frames. And it's because I want to make sure that they are having the same indexes, or they're having the same number of rows. So now after I have run this, now I can check that everything looks perfect, or I only have 2017. So now that I saw that I only have 2017, let's figure out what is MD1 and what is MD2. The best way to go about this is basically call the unique function and see the unique values on each and every one of them. So the MD1 has from 1 to 12, so we know right off the bat it's a month. Before running the MD2, we're expecting to see, you can see from 1 to 31. So now I know MD1 is month and MD2 is day. So I can go ahead and change the column's name, and now I can see that this is month, day, and year. So I can easily now join the date df to df. And now I have, a data frame that has date, time, consumption, month, day, and year. And if I wanted to Boolean mask, group by based on any of these, I could do that very simply. So on challenge 4, I want to be able to now add another date, another column here that is going to tell me what weekday, specifically, is it Sunday, Monday, Tuesday, Thursday, so like what weekday each of these rows are. And because we know the month, day, and year, we should be able to come up with that data. So this is something we've already done before. I'm going to show you one more time how it's done. I've never spoken through it, but let's do it one time here. So the best way to go about this is actually create a function and apply that function to each of those rows. And in that function, I'm just going to use month, day, and year. So I'm creating that function, and I know that I want to apply the function of this function to a data frame. So I input row, as in I want the whole row. And I get the year, month, and day, and I transform them into integer. And then I use the date time module, another very useful module, to transform year, month, day into this new object as date time. And this new object, date time, has a function weekday that basically spit out a number from 0 to 6, and 0 represents Sunday, 1 represents Monday, and Tuesday, so on and so forth. And now that I have the date, so basically it's going to be a number, I have created a dictionary here that tells me if it's 0, I want it to be Sunday. If it's 1, I want it to be Monday. It's basically making sure that I don't have numbers, I have actually these strings that are more intuitive. And I return whatever that number is. I pass it through the dictionary, and the dictionary is going to spit out one of these 3 letters that represent day. So I create this function. Now I apply the function to the data frame, and I say axis 1. I remember when I say axis 1, it means I want it to be applied to the rows. So now I run this. Now I get all of the for every row, I get one of these 3 letters which represent the date, weekday, which represent the weekday. So now I can, transform this weekday into a data frame simply by passing it through the data frame and change the column names and join that to the data frame I already had. So I'm just creating a df to join, as if I don't really care about this data frame. I'm just like using this line of code to create this df to join it to this df I already have. And this is the df, this is the main df I'm investing in, trying to do all of the pre-processing in it and like have the data ready for the next steps. So once I run this, now I will have also a weekday added to my data frame. In challenge 5, I also want to understand, so we understood everything about the data, and we did a lot of data pre-processing, and we have sort of teased out everything that could have been teased out. Now I want to have a closer look at the time. Look at the hour, minute, and the second, and see if there are even like completely useful, all of them. Do I need all of them or not? So it's fairly simple, very similar to the date. So I this time split based on the colon. I know this is hour, minute, and second. Once I run this, I'm going to have a new data frame, hour, minute, seconds. Now I can see the unique values. I can see the hours are from 0 to 23, the minutes are from 0 to 45, and the seconds, all of them are 0. So there is not going to be any seconds in the data, so it's redundant. So I'll go ahead and drop them. And also join the time df to my data frame. So I have hour and minute, and now I'm like, my data is becoming more and more codable, and I can be doing group by based on different things. I could be doing Boolean mask. So it's that is the idea of data preprocessing in this example. So let's look at challenge 6. In challenge 6, we are going to create a function that is going to sort of help us see how many missing values we have in the data. And we're going to be using this function throughout this module, not this video, throughout this module. So let's take a look at it. So basically, I'm creating a function. I'm calling it missing value reports. It takes in a data frame, and it reports the number of rows that data frame has. So whatever it is, the number of rows. And then also, it reports the number of missing value. So the way it does calculate the number of missing value, it says create a Boolean mask first that is going to be false or true if consumption is null. If it's null, it's true. If it's not, it's 0. And then it changes. Let me actually do it this way. It transforms those booleans into integer. If it transforms boolean into integer, false is going to be changed to 0, and true is going to be changed to 1. So it's sort of like a easy way to count the number of trues, basically. Because all of them are 1, now I can simply say sum. Because zeros are zeros, two trues were 1, now all of the trues are going to be counted. I create this function. Now I just call out the reports. I see that I have 35,000 data rows, and I have 16,000 missing values. So there are a lot of missing values in this data. We are going to see how we can deal with these missing values in the next video.